Hello, everyone. This is Kristen Rizak, and this is my final project for Data Mining 1. And I decided to do an analysis on Kaggle or Kaggle. Not really sure what it's called, but I decided to do an analysis of one of the challenges. So the challenge that I decided to do is called the Veto Demand Prediction Challenge. And what it does is it predicts demand for an online classified advertisement. Again, I did this analysis on the Veto Demand Prediction Challenge, which predicts demand for an online classified advertisement. The question is, what is a veto? And a veto is Russia's largest advertisement firm. I've included a link, and if you actually click on that link, the website is 100% in Russian. Um, the quality of advertisement image significantly affects the demand volume on an item for both advertisers and a veto. So it's important to use authentic, high quality images. And so this challenge is really, how can we come up with the most efficient and effective tool? So as you can see, there were 1,871 teams that were in this challenge. And I decided to kind of focus on the winners because that's what I do. And the winners were Dance with Ensemble, made up of four incredible people. I think that they're incredible because their work was amazing. And so these four people are Arsenal, Little Boat, Georgie, probably doing so bad at his name, and then Thousand Voices. And again, you can see the fun notes. They scored a 0.21501 and they beat out the second place team by a percent. And you say, oh, it's only a percent, but again, there was over 1,000, almost 2,000 teams, and they really had a 0.1% chance of winning, and they did, which is incredible. So, an overview of this challenge, we have a couple of categories. And so the description is when selling used goods, a combination of tiny, nuanced details in a product description can make a huge difference in drumming up interest details. Like we have well taken, authentic photos. I know you like my very straight line there. And that would be if a photo is too glossy, if a photo is authentic, if the photo is of poor quality. And then another subcategory that we have is believable, that the picture is believable and informative and descriptive. So again, we have three little categories under that, and it's unlikely, informative, and poor quality. So unlikely would be like, amazing watch for sale. Don't miss the deal. It's the deal of the century. Very unlikely. We have informative, I have an adjustable, and I'm just going to say Rolex watch for sale. It's never been worn. It's still in the original box, battery included. Eh, it could be more informative. And then we just have poor quality, which is, fancy watch for sale, no low ball offers, cash and carry. That doesn't tell us anything. And so down here, it is, and even with an optimized product listing, demand for a product may simply not exist, frustrating sellers who may have overinvested in marketing. Avito, which again, Russia's largest classified advertisement website, is deeply familiar with this problem. Sellers on their platform sometimes feel frustrated with both too little demand, and that would be indicating that something's wrong with the product or the product listing, or too much demand, which is the complete opposite. It's a hot item with a good description, but it's underpriced. And again, speaking about this competition, Avito challenged teams to predict demand for an online advertisement based on its full description, title, description, images, etc., its context, geographically where it was posted, similar ads already posted in this kind of analysis and how Dance with Ensemble made their models, they didn't really touch on anything with uh, demo geographics or just anything geographic. And historical demand for similar ads in similar contexts. With this information, Avito can inform sellers on how to best optimize their listing and provide some indication of how much interest they should realistically expect to receive. So this slide is about the available data. And there's so much data, and I'm not really going to go through it all. I will go through the train, but we have our train data, our test data, our train active data, which you can see is a supplement data from ads that were displayed from the same period as the training data, same schema as the train data, minus deal probability, image, and image top one. We have our test active, we have our periods train, and all of these are CSVs. We have our periods test CSV, our train images, our test images, sample submission, and then we have our train images with zip. So this is kind of, well, it's a zip file. And so these are the exact same images as you'll find in the train image zip file, but split into smaller zips, archived. So the data is easy to download. It's easier to download. So as you can see in the train data, right, which is basically the same as the test data. The only thing is that the test data is not going to have the deal probability. We have the item ID, user ID, region, city, and this is all parsed by ad. So remember, this is how we can effectively utilize this market for Avito. We have parent category name, we have parameter 1, parameter 2, parameter 3, and these are optional parameters, and it's based off of Avito's ad model. We have the title of the ad, description of the ad, the price of the ad, item sequence number, activation date, user type, image, so for the image, because this is a data set, it is the ID code of the image, which ties to an actual JPEG picture. And again, not every ad has an image. And then we have image top one, and then we have deal probability. Deal probability is vital. The target variable, this is the likelihood that an ad actually sold something. It's not possible to verify every transaction with certainty, so this column's value can be anything from a float from 0 to 1. This challenge, it really focused exclusively on tree-based models, XGB, which are the extreme gradient boosting, which is used for supervised learning problems, where we use the training data with multiple features, X to predict a target variable Y, LGB, which is like gradient boosting, performance, and it's a fast distributed high performance gradient boosting framework based on decision tree algorithm used for ranking, classification, and many other machine learnings. And then we have NN, which is, this should not say like, it's the neural network. And this is for forecasting models that are based on simple mathematical models of the brain. So down here, you can kind of see the paths for each of these. So we have, for the XGB, the leaf-wise tree growth, you kind of see, the path on how that works. Like we can say, if this was, oh, are people between the ages of 1 and 10? Everybody that is right here, everybody that isn't here, and then you go on from there. Then we have the LGB, which is a level-wise tree growth, so it's a little bit different. And then we have the NN models, which, as you can see, the one that was analyzed and used were the nonlinear relationships. So you can see that there are multiple layers. And you can see this kind of like hidden layer right here, which is proved vital within some of the models that they did. And overall, the team trained 6 base XGB models, 4 level 2 XGB models, 13 base LGB models, 12 level 2 LGB models, and how they won is they were able to get one of their base LGB models down to 0.2138. So for a while, they got it down to 0.215, and then they were able to add a few more variables, which got it down. So there are 5 key categories within the feature engineering. We have text features. So text features are kind of broken down into 2 subcategories, XGB. They kept the features sparse. And then we have LGB, which they used SVD, singular value decomposition, and OOF rich features to keep it a little more diversified. Again, multiple combinations were used. Examples would be just title, description, title and description, title description parameter 1, etc. And they had text stats, so word lengths, number of characters, number of words. And again, there were various levels, title, description, etc. Unique words and title additional to the description. So there are a lot of different there are a ton of combinations that you could use. You saw the data that all the data that they were able to use, and so a ton of combinations, and just between 4 people, is a lot. Next, we have image features. So within image features were 6, again, little subcategories, and so this is how they kind of got the image statistics. So if a picture is too dull, is the picture very dull? And from there, they had an image dullness score. I'm not going to go through all these, but you can just kind of see, dull images are not good for advertisement purposes, blah, blah, blah. Wave whiteness is the image very white. And again, an image whiteness score was produced. Uniformity is the image too uniformed. And so to get this, they use average pixel width, colors. What are the top colors used in the image? And for that, kind of 2 things were used, dominant color and average colors of image. We have dimensions. Is the image too small? Is the image too large? And with that, there were 3 even subcategories, and that would be width, height, and size of the image. And then, of course, which this is, extremely vital, is the blurriness. Is the image too blurry? And that would be the width of the image. So again, going back to those 6 subcategories, the dullness, the whiteness, and the uniformity are the 3 that are on this slide. You can see the code that was used for dullness. And so the output is down here, and it names the image and it names the dullness score. So this right here, woo, I'm so good at this, is a picture that it actually got 100 in dullness. So the higher the number, the more dull the picture is, and you can see you can't even really see what that picture is at all. It's extremely dull. We have whiteness. So again, the higher the number, here's the output. Higher the number, the more white the image is. And so this is a very white image. Yes, you can see this kind of silver bar, but the picture is just completely, there's a lot of white space. Then uniformity, which again, we did the average pixel width. You can see the code and the output. And I also included an example of a picture that just it needs to be spread out. It's just too smushed. Moving on to the last three, we have colors, dimensions, and blurriness. So for colors, you can see that the R code is right here in the output. And then from the output, the image is split between the RGB colors, which is red, green, and blue, to kind of separate and to see what, being that those are dominant colors. So we have the dominant colors of the image and the output. Oh my gosh, I'm so bad at this. And then from there, you need to get the average. And so we have the average, our output. Oh, I'm sorry. This is the output, and then this is the code or the query. So with dimensions, again, you can see that the output is, the width, the height, and the size of the image. And you can see that this is actually a full table. I just split it into two to kind of make space. You can see the image, dullness, whiteness, average pixel width, dominant, red, green, blue, average red, green, blue. And then this is what we have, the image size, width, and height. Then we have blurriness. And going back to the first three, I included the R code, and then this is the output. So again, if, and you can see that this 55 is extremely blurry. The higher the number, the more blurry the picture, and you can see that this is an example of a picture that is just way too blurry. Okay, going into the deep dive of the NN models, this team compared the performance of three pre-trained deep learning models implemented for Keras, and which is an application that kind of uses these three categories. In the models, we have the ResNet 50, Inception v3, and Exception, which again are all pre-trained on the ImageNet dataset, and they utilized them and plotted a few images from Avito's image set and the probability of their top qualifications. So again, this we have the R output. And these, I know they're really small, but these are a couple of the output examples. So you can see the image right here. Oh my gosh, I'm sorry, I'm really bad at this. And then how they scaled 0 to 1 for the ResNet 50, the Inception v3, and then the Exception. Moving on, another subcategory would be the correlation with deal probability. So that would mean if the image is ambiguous to the classifications neural network, it will be ambiguous to a human being and unattractive as a product. To verify this, you need to measure the correlation between the top class's classification score and deal probability to have a reference to measure against, obviously, and then you can compare it to the correlation between the advertisement's title or description links with the deal probability. And again, we can see kind of what they use for R and then the output. So examples of a low deal probability and high deal probability pictures. You can see, I mean, this picture is terrible. These pictures are just not very good. And so they fall into that low deal probability. And then we have these high pictures like this. That picture is really good and cute. I like those nails. So again, continuing with image features, we have this output, which was shown before, which is the correlation between deal probability and strong model predictors. So the correlation between deal probability and image confidence show that N in this feature, in the picture that I'm showing you right now, is similar or stronger than that with title length and or description length. So because these competitions there's so many of these competitions, they had to use a smaller sample. So they used a small sample of 1,000 images due to disk space restriction, which is completely understandable. And then on the right, again, there's another correlation graph that deals with deal probability and shows that there's good correlation again with description length, title length. And so these two visuals are kind of the same, it's just different ways to show them. Now we move on to the categorical features, and as you can see, they did counts and count unique features on various levels. Again, there were multiple combinations that could be used, and they targeted, encoding at a ton of different levels. And one of the things that they did use is they included the mean deal probability for categories with count greater than 5,000, which means that they got rid of outliers. And you can see that also they had a rule for the OFF data, mean deal probability encoding, and so they had a little filter for that as well. And some of the categorical features for deal probability. So on the left, we have the distribution of deal probability, and it's clear that the majority of the items have extremely low deal probability, about 78%, while very few values have the deal probability of 0.7 or larger. Very small tower is observed near the deal probability of 1.0, indicating that there are some items in the data set having very high value of deal probability. And on the right, I just thought this was interesting. It's the distribution of user type, and you can see if it's private, a company, or a shop. And the majority of the items are posted by users which belong to private user type, while minority of items are posted by users which belong to shop user type. About 72% of the users are of private type, while 5% of the users are of shop type. There were a ton of different deal probabilities that were used. Again, this specific team did not use geographic features, but there were some deal probability outputs from other teams, and you could see, where are these ads coming from in Russia? What cities are they coming from? The make of people, the kind of the behaviors and different trends. So the predicted independent variable features, at the end of the day, after all this testing, they picked four variables, which was price, which is ad price, image top one, which is Avito's classification code for the image, item sequence number, which is the ad sequential number for users, and then day difference, which was run off of an RNN predictive model, which is the day to day from, which it's trained on active and period dates. Okay, after all of that training and testing, we finally have the engineering steps, and you can see that three steps. We have calculations, then you need to aggregate the data, periods table to item ID, level, activation count, and then third is another level of aggregation. So in conclusion, again, this analysis was extremely deep in the tree models. It was a lot of fun. This is kind of a smaller version of what this team really did and the depth of which they did it in. Again, I just showed how many models they trained, and at the end of the day, they used some of all three of these models, the XGB, the LGB, and the NN models for the first layer. The second layer, again, all three. And then for the final layer, which got them to that 0.213, was only the NN model. And that's what made them the winners. Yay! And I am done my presentation. Again, this is Kristen Rizak. Thank you for listening. And I encourage anyone and everyone to check out this competition. It's this team was very interesting to look at, but there are so many other teams that were amazing. And just in general, if you don't really check out this competition, this website will help you learn, data mining and um, you know, just help you learn and get you better in the field. Thank you.